Okay, so in our last video, we began to graph a basic log base 2 function. So we just changed this to the exponent form, which is 2 to the y equals x, and we plugged in values for x and plugged in values for y, I apologize, and got our x values, and we graphed it. And we got something looking like this with a vertical asymptote of x being 0 right here. This line will never go like that. That's what we concluded. And I said that we will do an example where it's not a log base 2 and we have these hairy transformations. Okay? And we will do them, don't worry. I wrote my steps that I always use when I graph transformations right here. They're just in short form. And we will begin to graph right here. So we got 4 log base 4 x minus 5 plus 3 equals y. Okay? Or this could be here, it doesn't matter. Alright, so first things first, let's find out what the parent function is. Well, technically in log form, we eventually want to change it to exponent form, in exponential form, to the exponential form. But first, let's understand how it looks in log form. So the basic parent function for logs is this. So we got our log, of course. So just eliminate all these crazy transformations. The base always remains the 4. We got an x. Forget the 5, forget the 3 equals y. This is our basic parent function in log form. What if we want to change it to exponential form? Not to exponent form, however you want to say it. Well, remember that this 4 is the base. This y is the exponent. And the x is your answer. There you go. And we are going to use this because this is so much more easier to understand than this, right? So, second step is to make a table of values. Let's do that. Alright, and remember, we are picking y values, right? Because if we just plug in a y value, we'll get our x value. That'll be easier. So, I'm going to pick 1, 2, 3. Okay. If I put now let's just plug them in. 4 to the negative 1, it's 1/4. 4 to the 0th power is 1. 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. Alright? Sorry about the noise outside. Okay, great. We made our table of values, and we got the parent function. Let's do the third step. So now we have to basically analyze the x's and the y's. Alright? In our transform function. What is happening? What is the difference between this and this? Right? Well, let's look in here. Right? Recall that whatever is in the bracket is applied to the x's. So what do we have here? Well, we're just subtracting 5, right? But remember, when it's inside the bracket, all the operations, addition, subtraction, they're the opposite of what you see, or what it's trying to imply. So we have a big subtraction right here, but it's actually, what is the opposite of subtraction? Well, it's addition. So we are not subtracting 5, we are adding 5. Alright, so to our x's, I always do this if you watched my other videos. What's happening to the x's? Well, we're just adding 5 to all our parent graph, parent log function x values, So we took care of the x's because there's nothing more in the bracket. It's just minus 5 or add 5. What about the y's? Well, we got this 4 and this 3. So just remember whatever is outside the bracket, which is this and this, is applied to the y's. Okay, I know it's very messy. But whatever is outside to the y is inside x, okay? So remember, in front, you multiply. So whatever the value is, you multiply by that value to your y's. So here we are multiplying by 4. And what else are we doing? Well, we have an addition, so we are adding 3. Okay? Now, it just says apply to parent graph. So we just apply these numbers, kind of distribute, and do the arithmetic. That's what we have to do. Alright, 1/4 plus 5, that's going to be 21/4. Alright? And that's going to be around 5.25, I think so. Yeah. What about why did I do that? I don't know. The 1. If we add 5 to it, well, we're going to get 6. 4 plus 5, that's 9. 16 plus 5, that's 21. And 64 plus 5, that's 69. Okay? Yeah, so we got our x values. These are our new x values. Okay, I hope you can see what I'm doing here. What about our y's? Let's do the same thing. -1 times 4 is -4. -4 plus 3 is -1. No, what did I do? Did I do this right? Oh yeah. Sorry, yeah, I didn't. I was looking at my paper. I thought I was doing something wrong. Okay. Excuse me. 0 times 4 is 0, plus 3 is 3. 1 times 4 is 4, plus 3 is 7. 2 times 4 is 8, plus 3 is 11. 3 times 4 is 12, plus 3 is 15. Okay. We're done. We got our... So we did the hard third step, and we are done. We got our new x values. All we gotta do now is plot and graph. So let's do exactly that. Do I bring here? Yeah, I do. Let me just, this line is bothering me, so I'm just gonna remove it. I am gonna use a line because I know my skills literally suck. Can't even make a line. Okay, that's good. Yeah, so now let's graph. Oh, I need to teach you one more thing. So, remember I was talking about vertical asymptotes? How since we are graphing the inverse of the exponent. Remember in exponents we had horizontal asymptote. And now we are basically doing the opposite, which is vertical asymptote. Well, you might be thinking, well, how do I find? So I know it's messy, so I'm going to copy it here. How do I find the vertical asymptote in this function? Well, all you have to do is set this, the inside, to 0. It's what x can't be. Okay? So if you set this to 0, you will solve it to get x equals 5, meaning x cannot be 5. So before you graph, you want to do this. 2, 3, 4, 5. It's a vertical asymptote. It's not a horizontal. It's not like this anymore. Look at this. So you want to plot this line right here. And you'll see that the line will never... You'll see. I don't want to ruin it for you. It's an exciting moment. Alright, let's start. So we got the first value, 21/4 or 5.25, -1. So 5, this is 5.25, so it's there. negative 1. Alright? 6, 6, 3. So 6, 3. 3. 9, let me see. Yeah, 9, 7. So 6, 7, 8, 9. What was it? 9, 7? I am terrible. So 9. See, I am really guessing. But this is how your graph will look like. Don't worry, I'm not changing the graph. 21, 11. Now I have to improvise. So say 21 is somewhere here. And 11 is somewhere here. Alright, and lastly, I don't know if I'm going to graph that. 69, 15. Let's make that 69. Of course, I graph. Whoa, no, I forgot about this. You know what? I'll just do this. 69, 15, so let's say it's right there. I don't know if you can see that. It's right there. But yeah, this is how our graph was. It's a very, large graph. And as you can see, if you continue to pick more negative numbers for y, say you pick, we did negative 1, right? Yeah. So you pick negative 4, negative 6. Pick that, plug it into this, get your x and transform it, apply the transformations, and see that you will get 5 point something, something, something. It's going to be somewhere here, and then here, then here, and that's how it's going to go basically. Get ultimately small. So I'm just going to make an attempt. You see how bad I am? My mouse. I'm sorry guys, I know I'm wasting your time. Let's say it looks like that, okay? That's how basically it's supposed to look. Yeah. So there's your graph. It's an odd looking graph, but it's a logarithmic graph. That's all you have to do. Yeah, just get your parent graph, transform it, apply the arithmetic, and graph it. Remember your vertical asymptote though. It's what x can't be. Set it to 0 and you will find your x vertical asymptote. It's very important to understand and also to, plot, show it on the graph. You have to make a dotted line basically. So thank you for watching and I'll see you in my next video.